Okay guys, good morning. Welcome to my physics class. Today we got a numerical on mechanics. We start with this numerical and let's try to solve this. The question, it says a marble rolls down from top of a big sphere as shown. So here you got this big sphere, and then there's a small sphere, there's a marble rather. So there's a marble which rolls down. So this is the marble. We can, there's no numbers given, so how about we take the mass of the marble as m, and this marble rolls down the sphere, and we are asked to calculate this angle theta. The theta is the angle when the marble is about to leave this sphere. So it is in fact leaving this trajectory. So how to crack this question? The first thing you need to understand that as the marble rolls down, it actually gains velocity. So when it rolls down, it gains velocity. It means that there's a bit loss in potential energy. So first we need to calculate what's the loss in potential energy, because you got to understand that the marble has reached at this point. So obviously this height is the one that is responsible for the loss in potential energy. So first let's try to calculate what's the loss in height. So by using simple rules of trigonometry, you could calculate in this triangle, since this angle is theta and this is r, the radius. So this would be in fact r cos theta. So this you get as r cos theta. So the loss in potential energy in fact would be mg times r minus r cos theta, because r is the total radius. So r minus r cos theta would actually give you the height. So we would start with the loss in the potential energy. So we would calculate what's the loss in potential energy, and that gives you mass times the gravity times the height, and the height is in fact that's the loss in the potential energy. So that would be in fact r minus r cos theta. So this would be r minus r cos theta, and obviously this has to be in brackets because this is what we are calculating as the height. So I would further simplify this, and this would be mg r, and I would do this as 1 minus cos theta. So that's the first thing. So that's the loss in the potential energy. But obviously this loss in potential energy is providing it kinetic energy. So that's the gain in the kinetic energy, because as the marble rolls down, its velocity increases. So that's a gain in the kinetic energy. So we would find what's the gain in the kinetic energy. Gain in kinetic energy, that is equal to half mv squared. So that's half mass of the marble times the velocity squared. Now we know that by the rules of, or by the laws of conservation of energy, the loss in the potential energy got to be equal to the gain in the kinetic energy. So we could equate these two equations, and we could say mg r into 1 minus cos theta. 1 minus cos theta is actually equal to half mv squared, half mass times velocity squared. Now you could cross out the masses. So when you cross out the masses, you actually get a function for the velocity. So you could say velocity squared is actually twice g r, and this is 1 minus cos theta. So that's the first equation we are getting. So we get an equation for velocity, and I would actually like to put it in a box so that we can use this equation later on. So that's the first thing, but still our work is not yet over. We just calculated the velocity, but but in fact we are supposed to calculate what is the angle. So how about understanding what's the angle like? So let's try to resolve the forces, because now we need to involve bit of forces. So how about this angle is theta, so obviously this angle is theta, you guys know that, and then we try to resolve the forces. So when you resolve the forces, obviously by the laws of trigonometry, this force is going to be mg cos theta, this force is going to be mg cos theta, and the mg was acting vertically downward, that was given by this one, so that was mg, and obviously there is a reaction force acting outwards, and that's the reaction force is R. Now the point where the marble leaves the trajectory, that point the reaction force is going to be 0, because that is the point when the marble has actually left the sphere. So obviously the reaction force, there is in fact there is no upward reaction force, because the reaction force is offered by this bigger sphere. So obviously since this has left the bigger sphere, so there is no reaction force. So let's try to incorporate that part. So let's try to calculate first what is the net force acting here. So the net force would be, in this part, would be mg cos theta, so that would be mg cos theta minus r, that would be equal to mv squared over r, because that's the force along a circular motion. So I would take the capital R here, because we have taken this as the capital R. So how about we take the capital R to make sure that there is a uniformity. So mv squared over r. Now at that particular point r becomes 0. Since r is 0, so you get mg cos theta is actually equal to mv squared over r, and then you could cross out m's. So you could from here you could actually get an equation, v squared is actually equal to, if you cross multiply, you are going to get gr, that's, I like writing this funny g, gr cos theta, dr cos theta. So you get another equation, and that is v squared is gr cos theta. Now so what we could do is that we could equate these two equations. I could write this as the equation 1 we got, and this was the equation 2. So how about we equate those two equations and try to get the angle theta. So I would use again the black marker. So I would say 2gr 1 minus cos theta is actually equal to gr cos theta. So now, I mean, obviously you could cross out gr, so ultimately you get 2 minus 2 cos theta. 2 minus 2 cos theta is actually equal to cos theta. So how about you take this to the other side, so you get 3 cos theta. 3 cos theta is actually equal to 2, and so obviously you get cos theta as equal to 2 over 3, and then we could use calculator, and we could use theta as the cos inverse of here we get cos inverse of 2 over 3, and I could use the calculator to see what's the value of theta. So yeah, here you get cos inverse 2 over 3, that's 48.18 degrees. So you get 48.18. So obviously I could write as 48.1, or how about we round it to 48.2 degrees. So that's how we solve this question. So obviously this angle is 48.2, at which the marble leaves the big sphere, and that's all.